Okay, so this is going to be a short tutorial on how to write your method section for your term project in GIS 200. So first let's talk a little bit about the basics, how they should be constructed. They should not read like a set of step-by-step, click this, click that kind of instructions. The purpose of the method section is not to inform someone exactly how to use the software, like as in I searched for the such and such tool and then opened the tool up and selected this from the menu. I don't want things like that. Second point, these methods should be in sentences and paragraphs. They shouldn't read as bullets. They shouldn't be listed as a chart or anything like that. They should be a narrative story telling what you did. And they should follow the order you undertook to complete the project. Minus, of course, any wrong turns or missteps or things that you had to do over. Think of it as once you figured everything out, if you were to go back and do it again from scratch, how would you do it? That's what this should be. And this section should provide enough detail that any quote-unquote GIS person could repeat what you did. So how to get started? You need to begin with an outline. And the reason is, this is something you can't really fully write yet. You won't be able to finish this section until you've nearly completed your project. So your methods are going to be somewhat incomplete. But if you sketch out an outline and fill it in as you go, when you complete the project, you can go back from the outline and write your methods. And so I'll sort of explain what I'm talking about. When you're writing out this outline, it should start with the data and then talk about things like the preconditioning, the concepts and products and geoprocessing steps and data and maps and tables and answers and all that sort of stuff. And what you want to do is leave yourself room in the outline to write notes about what you did or why you did it. And as you complete the model, you fill out the outline. And then when you're finished, you convert it to a narrative describing what you did based on the notes that you've got on your outline, and everything will work great. Now, I don't want any of this turned into me. The only thing that I want is ultimately at the end of the day is your completed method section in your final report. At some point in time in a few weeks, I'll post a link where once we get to the point where I think you have your method sections done, that I will take a look at them if you like and give you feedback. So here is sort of what that outline would look like in the totality of it all. Data. What data? Where did you get it? What do you plan to do with it? Preconditioning things. What format did the data come in? Were there any issues with projections? What was the data? Did you have to do any queries or reclassifications, that sort of stuff, before you could actually begin to do things with it? And then sort of the concepts or products. I'll lump them together a little bit. What steps you're going to do to or make from the data. In other words, are you just going to reclassify it and look at it, or are you going to take the data and then create a new elevation layer that only indicates the places that have elevation over a certain amount, or a reclassified land cover that only identifies the proper forest type for habitat. Those would be some examples of what are some of the concepts and products, and these are the things that you would kind of list here. And the main reason is you don't want to lose sight of making sure that as you're writing your narrative and describing what you're doing, that you explain why you're doing it and what it's going to be used for. Ultimately, next will be your geoprocessing steps, and this is the thing where we talk about how we put the data together. The overlays, the spatial joins or the joins, and the products that those layers or those steps or those processes produce. And then ultimately from that, what sort of maps or tables would one make? What's the output that you're going to get from those geoprocessing steps? What is the meaning of that output? How do you interpret those results? And ultimately, how does that lead to an answer to your question? And so that's sort of how you would sort of go through and sketch out your outline. Now, what does that actually look like? Well, I've started one off for you. I'm going to give you a bit of an example. So, what would the example look like? It would look something like this. I've allowed quite a bit of space here, and I'm just going to walk you through the first section, which is the data section, for the class project. Now, it's not going to be exactly the same for everyone. The elevation layer probably will be. The land cover could be, but there's another land covered layer that would work as well. And perhaps some of you have selected projects that require an additional element, like the counties or the roads or something like that. That would be in addition to this. But these two are pretty good examples of land cover and elevation, like most of you would use. So it would look something like this. What data? Underneath of bullet 1A, subheading what data, and then I would list the data. Elevation data, a digital elevation model of West Virginia, a 30-meter one. And then land cover data, the NLCD 2006, which is a 16 class classification. And that's just a basic way of reminding me what it is. Takes us to the next step, which is where did you get it? The DEM was from the NED, or the National Elevation Data Set, via the WVU GIS Tech Center. The NLCD was from the Multi-Resolution Land Characteristics Consortium, via the WV GIS Tech Center. Where did I find this out? I found all this out from the Tech Center's webpage when I looked at the data before I started downloading stuff. I took a few minutes and read things. That's where you find answers. Next bullet, the next point is C. What do you plan to use it for? And then I just basically lay out in the most simplest terms the digital elevation model to ID extents over 900 meters. In other words, to find every place that's above 900 meters in elevation. And the NLCD to identify suitable forested lands. Not just forested, but forested to meet my criteria for my model. And you notice how there's an awful lot of space on this. And here's why. Say I go up there and I start working on this, and I find that 30-meter DEM is coarse and works okay, but it's not perfect. My land cover turns out to be at 3 meters. What am I going to do? Well, likely I would probably go back and either look for a 3-meter DEM of elevation, or I would look to change the land cover data to 30 meters. But I would most likely change one of those two, or I'd look for another land cover that was in a 30-meter raster. Both of these are perfectly fine solutions. They each have their own unique problems, but that would allow me to make note of that. It would also allow me to make notes of things like the metadata was on a separate download link, or make sure you download the I downloaded the one with the that was in a GCS or something like that. These are the kind of things that you can sort of make notes of. Where did you get it from? As long as you're not using something else, it's going to be the exact same thing that I've got here. How do you plan to use it? Well, depending on what your question is and what the data is. For example, if you had roads and you're trying to identify which roadside would be the best place to watch for flying squirrels in West Virginia, if that was your question, you would, obviously use the elevation and the land cover to identify the flying squirrel habitat, and then you would figure out which roads intersected the most habitat, and that would be the thing that you would need. So what you would have to do next would have to have obviously not just these two data sets, but you'd have to have the roads data. You have to explain what they were, where it came from, how would you plan to use it, and it would be simple to identify the road with the most immediate proximity to habitat or something of that nature. And so that's how you would do that. The point is, if you go back to what I had a few slides ago and that longer list of different things that could be on this outline, as you fill it out, understanding what you're doing and making notes on it, when you get done you'll have this long completed set of notes that you could then use to go back and write your method section. And so I'm not going to give you a complete set of notes, but I will speak as to how you could write this up just from what I have here. So you would start off with talking about your data and your method section, and said to answer the question, and you could restate whatever the question was that you're trying to answer, requires elevation data and land cover data, period. For elevation data, I utilized where we utilized a 30-meter DEM of the state of West Virginia and the National Land Cover Data Set from 2006, which was a 16-class classification of existing land cover across the entire state. All the data was acquired from the West Virginia GIS Tech Center. The digital elevation model came from the National Elevation Data Set. The NLCD was developed by the Multi-Resolution Land Characteristic Consortium. The DEM was used to identify all locations with an elevation above 900 meters. The NLCD was used to identify all the suitable forested lands for flying squirrel habitat, period. And that's how you would basically convert those into, and if you were to go through that entire outline that you filled in just like that, you'd have a nice, wonderful, concise, to the point method section. If you have questions about how to write up parts of the steps when you get down into the further sections, I'm here to help. See me before or after class during office hours, or shoot me an email. I'd be happy to work with you to try to improve what you're working on. So hopefully this will help you have some idea of where you need to be on your method section. So from this point, you probably have just got a question figured out and you've written up an introduction. And so the next step would be to sketch out an outline like this and start filling in the things that you know for sure, which pretty much is going to be not a lot. And then after spring break, we're going to talk about data and how to find it and where to get it and how to write about it. And when we do that, you can begin to start to fill this in, and then as we get into geoprocessing, some of the next steps in the methods will fill out, and by the time we get through all of that, you should have a pretty good idea and have everything pretty well squared away. And when we get down to the last couple weeks of class, it'll just be a matter of tying it all together and making a nice report. So I hope that helps. Enjoy your spring break. Come back energized and ready to go. Thank you.